This next question is possibly the hardest question you're likely to get with respect to finding the range of a projectile. There are two methods in which you can use to solve this method. The first method does not involve a quadratic equation, the second method does. I'll talk you through the steps for the first method. I'm assuming most people who are going to prepare themselves for a question like this will be using the quadratic equation. It is only for those students who have got a very good understanding of projectile motion. Okay, for the first method, the first step is to find the time taken to get to the maximum height. And you can see in the diagram over here, I have labelled the maximum height. The second step in this method is to determine what is the maximum height above the launch point. So we're looking for calculating that distance there. The third step in the solving this question is to add the maximum height here plus the 50 it's got to travel before it comes back and hits the lower level. So what we have there is Sy plus S50. The lower level is this level down here, which in this case is water. The next step is to determine the time taken now to travel from this maximum height all the way down to the water. Step number 5 is determining the total time taken for the projectile to go from this point all the way through its trajectory. Now this is going to be equal to the time taken to get to the maximum height plus the time taken to get from the maximum height down to the water. The last step in the process is to determine the range, which is equals Sx, which is equal to Ux t plus half axt squared. Now as ax is 0, this becomes 0, so it's simply ux, which is going to be 50 cos 60 multiplied by total time. Now this total time is the one that you found in step 5. So in a summary of this method, we have the time taken to get from the launch point to the maximum height. Then you have to work out what is the maximum height calculation. You've got to add the you've got to add the total or the maximum height to the 50 meters to get the total height above the water. Then you have to determine how long it takes the projectile to fall that distance. You then have to add that time to the previous time to get to the maximum height, given the total time of flight, and then finally the horizontal range is simply given as the initial horizontal velocity times that total time, as the acceleration in the horizontal direction is 0. Okay, the quadratic method is quite simple if you know your quadratic, or if you're good at algebra. Right, let's have a look at this situation here. We have to quickly write down the data from what we know from this question. So you can see here that I've got Sy is minus 50 meters per second, or minus 50 meters, but it starts here, up is positive, but it ends up below where it started from, so it's minus 50 meters. That's very important. Uy is 50 sine 60 degrees, that's that component there. Ay, of course, is minus 9.8 meters per second squared, which means it's minus 9.8 meters per second down, and we're asked to find the time. As soon as we find the time, we can determine how far across it goes. The next thing we need to do is to substitute that into a formula. The formula we're going to use is S is equal to ut plus half at squared. Now apply that to the vertical direction. We get Sy is equal to uyt plus half ayt squared. the next step is to substitute the values here into this equation. When we do this, we get the minus 50 is equal to 50 sine 60 degrees, that's uy, t, plus half ay, which is minus 9.8, t squared. Moving down to here, the 50 sine 60 degrees comes out to 43.30 in your calculator. And you notice here it's gone from a plus to a minus because it was minus 9.8. So it's minus 4.9, half of 9.8, t squared. If you rearrange that into the form of quadratic, we get minus 4.9 t squared. We move that to the front, plus, there's a plus in front of there, plus 43.30. And when we move the 50 across the other side, it becomes positive, so it's plus 50. Now, if you write down the general form of the quadratic equation, you have over here x is equal to minus b plus or minus square root of b squared minus 4ac all on 2a. That's when it's in the form of 0 equals ax squared plus bx plus c. So if you look down here in this equation here, we're looking for x is going to be t, but the coefficients of those in that equation there, we find that a is minus 4.9, we have b is 43.30, and c is going to be 50. So all we need to do now is substitute those values into the quadratic. So we get there, we get the minus 43.30. You've got to be very careful with the minus signs and the positive signs. If you make one error there, the whole system will fall down. So there's a minus in front of the b there, so and the b was positive, but the overall makes a negative. Plus or minus b squared. Now look closely here, this is a minus here, but then we have a minus 4.9. So a minus will actually give a positive when we come to the next line here. Over 2 times a, 4.9 is a. So continue on that simplification. We get here 43.30 squared was 1874.89. Minus 4 times minus 4.9 times 50 comes out to be positive 980, and 2 times minus 4.9 is minus 9.8. Continuing on further, continuing on further, if we take this top sign, this sum up here, we get 10 plus 3 positive over minus 9.8 gives a minus 1.04 seconds. On the other alternative, when we use the minus instead of the plus here, we get a situation we come out in positive 9.87 seconds. Now, with the two answers, the answer you are going to pick is the positive answer, as you cannot have a negative time. So now that we have the total time of flight, it is simply working out how far it goes across in that time. So we're looking at the horizontal direction now. So the equation we use is Sx is equal to ux t plus half a xt squared. Now we know that acceleration in the horizontal direction is 0, meaning our equation comes out to be simply Sx equals ux times t. We put the ux in, which is the initial horizontal velocity, which is 50 cos 60 degrees, times the total time of flight, 9.87. Remembering 9.87 is the time we calculated using the quadratic for the ball or the projectile to go through the entire flight in one step. And that comes out to be 246.75 meters, and don't forget to put the arrow to indicating a direction there. So with that, we have got a quadratic, the use of a quadratic. You can see that's a lot more simpler, or the steps are a lot less than the previous method, but you do have to know how to use a quadratic, and very important emphasis must be placed on the signs of the data you put in. For example, minus 50, minus 9.8, plus 50 sine theta or sine 60, and when you substitute in there, there's minus signs here, there's minus plus sign there, there's a minus there. So be very careful with that. If you're confident though, yeah, go ahead and use the quadratic.